Hey, this is Dr. B, and let's solve a few molecular geometry and bond angle questions. The first one is for boron trifluoride. Boron has 3 valence electrons, fluorine each has 7. That totals up to 3 plus 21 is 24, which is a perfect match for having a full octet of each. That means we will have no lone pairs at all. We'll have a molecule that looks like this. Notice we have our 8, 16, 24 valence electrons just as calculated, so no lone pairs go on boron. Fluorine is group 7, so it always has its 3 lone pairs. We do have an incomplete octet there, but boron can apparently handle that. And the final answer is if these spread out as much as possible, you'll have 120-degree bond angles and the whole thing will be flat. Trigonal planar, 120 degrees. Next one. Xenon difluoride. Well, let's add them up. Xenon checks in at group 8. It's got 8 valence electrons, and each fluorine still has 7, so we're going to have 8 plus 14 is 22. That is way beyond the 16 you'd get if you just had 2 bonds and the 3 lone pairs each, right? That's 3 extra lone pairs. By definition, they go on what I call the landing pad, and I'll tell you what I mean by that. You spread them out not on the top and the bottom, but on this part here. If you have 5 things, you have the potential for a trigonal bipyramid. So you put all the lone pairs there, there, and there. They take up space, but they don't contribute to the actual geometry of the molecule. And so we call this thing simply linear. And that would be 180-degree bond angles, and it is linear. Last one, xenon tetrafluoride. And by the way, isn't it strange that a noble gas like xenon can be made to react? Go figure. Okay, let's add this one up. 8 valence electrons here, each of those at 7, so that's 28 for the fluorines plus the 8. That's 36. Now with 4 bonds at 8 electrons per bond, including the lone pairs, we should be at 8, 16, 24, 32, but we have 36. That's 4 extra electrons or 2 lone pairs. Put them on the landing pad and spread them out as much as you can. Therefore, 4 things plus 2 lone pairs is the equivalent of sort of an octahedral structure. That's 6 things total. 2 of them are lone pairs, and we're going to put them at opposite ends of that, what I call the landing pad. And if you look at this thing, and you can see it in 3 dimensions, we've got a square planar structure. Imagine here and here contain your fluorines each, as well as top and bottom. That's a square planar structure with bond angles of 90 degrees. That is 3 molecular geometry and bond angle questions.